Okay, welcome to the tutorial number 5 discussion. Let's look at the problem number 1. As shown in the figure, a double pendulum consists of two massless strings of length L1 and L2, and the masses of the bobs are M1 and M2. By applying the method of virtual work, find the value of theta 1 and theta 2, which are the angles that the strings make with the vertical when the horizontal force F is applied on the lower bow. So this is the question. So here we have given this is the theta 1 angle and this angle is theta 2. Okay, so look at the coordinates of this one. Let's call this coordinate as x1 and y1, this as x2 and y2. You can clearly see we can write x1 as L1 sin theta 1, y1 as L1 sin theta 2. Similarly, x2 as x1 plus L2 sin theta 2, which is equal to L1 sin theta 1 plus L2 sin theta 2. Similarly, y2, this coordinate y2 will be equal to L1 cos theta 1 plus L2 cos theta 2. So basically, if you look at it, even if we take the x coordinate and y coordinate, the Cartesian coordinate here, and take the same coordinate system for both bobs, we have to write it in terms of this both angles theta 1 and theta 2. So what are the generalized coordinates here? Generalized coordinates here are theta 1 and theta 2. Okay, these are the generalized coordinates. Okay, so now we have generalized coordinates. So if we make a virtual displacement by changing theta 1 by delta theta 1, so what will happen to it? So we have this delta x1, therefore, which is equal to L1 cos theta 1 del theta 1. Similarly, del y1 will be equal to minus L1 sin theta 1 del theta 1. In a similar manner, del x2 we can calculate equal to L1 cos theta 1 del theta 1 plus L2 cos theta 2 del theta 2, and del y2 is equal to minus of, I am taking the whole minus outside because there will be minus summing, because all the causes will become sines, minus signs. So L1 sin theta 1 del theta 1 plus L2 sin theta 2 del theta 2. This is what we get. Okay, now there is an external force on bob 1, and there is gravitational force acting here, mg. Both mg is acting here this on both bobs. On bob 1 it will be m1g, and bob 2 it will be m2g. Okay, and the total forces on bob 2 are, there will be one this external force F that you are applying also will be acting on muscle 2. So the external force acting on bob 1, let's write that first. So external force on bob 1, it will be just simply m1g y cap, and on bob 2 it will be f x cap plus m2g y cap. This will be the force. So what will be the total virtual work done by this virtual displacement? So that will be equal to m1g minus L1 sin theta 1 del theta 1, this is along, this is for the bob 1, plus f into L1 cos theta 1 del theta 1 plus L2 cos theta 2 del theta 2 plus m2g minus L1 sin theta 1 del theta 1 minus L2 sin theta 2 del theta 2. This will be the total virtual work done. So this mg is acting, this is along y, del y only we consider here, del y1, and then here it is del x1, del x2, sorry, and this m2g del y2. That's how Now we know from the principle of virtual work, the total virtual work has to be equal to 0. Now equate it, therefore since it is equal to 0, now you can find out the theta 1 terms and theta 2 terms separately. You can solve for them. Those are algebra, you already know. So from here you can calculate the angles. So tan theta 1 you will get equal to f upon m1 plus m2 into g, and tan theta 2 you will get to f upon m2g. So these are the solutions we have in the end. So thank you for listening to the video. Let me know if there are any questions in the comment.